All right, this is going to be part one of the final exam review packet for summer 2017. Starting with number one, we're going to be doing 1 through 9 in part one, and then every other part will also contain 9 problems worked out. So we're looking at simplifying this expression here that has something multiplied by something else. So notice there's nothing in between the two parentheses, so we're going to be doing times. And when we're looking at this, we need to answer only with positive exponents for our final answer. So since there's no adding or subtracting anywhere, we can go ahead and just start multiplying. So 5 times 4 would be 20. When you multiply x times another x, you add their exponents. So 2 plus negative 5 would be x to the negative 3. And then negative 3 plus 4, since these are both base y when we multiply, would be positive 1. So I didn't show all the steps for that, but we're multiplying the x's together. So notice, remember, that is the addition of the exponents. And when we look at this, we notice that we don't have all positive exponents. So this x to the negative 3 needs to move to the denominator. And once it moves, its power, remember, becomes positive. So that would be my final answer for number 1, 20y over x to the third. For part 2, we're looking at factoring a polynomial. It's a binomial. There's no GCF. You should always check that first. It's either going to have to be able to factor. It's going to have to either be perfect squares or perfect cubes. This one is perfect cubes because 2 and x both cubed would be 8x to the third, and 5 cubed would be 125. When we're dealing with perfect cubes, we had a formula pattern to follow. It factors into a binomial and a trinomial. The bases that they were, in other words, their cubed roots, are what's going to go in each of these spots, but there's a pattern to how we put them in. So in the first part, the binomial, you place the 2x and the 5 and the sign from the original problem in between. So 2x minus 5. For the parts over here, there are going to be 3 different locations in this trinomial. The first one is made up of multiplying the first base times itself, so 2x times 2x. The second position is made up by multiplying the first base times the second base. And when we talk about the bases, we're looking at this. And then the final position is made up of multiplying the last base times itself. So this would be 4x squared. This is a 10x, and this is a 25. Now, to remember your sign rules, we have a little saying called SOAP to help us remember that. Same as the original, so that's what S stands for. That's why it's negative. Opposite to the original, so since the original had a negative between them, this would be a plus, and this stands for always positive. Now, your final answer is not all of that scratch work. It's just the binomial times the trinomial. Okay? Number 3 is simplifying an expression. We're looking at one that is a little bit messy. It's a big expression that we're going to try to simplify, and notice the key factor here that I'm going to highlight is that there is a plus sign between these two pieces. So this is all being multiplied together, plus this is all being multiplied together. Typically the first thing I try to do is I try to simplify if there are any monomials, because we can't multiply all this out because these have exponents on them. You don't want to FOIL all that out. But if there's some monomials, you do want to combine them. So that would be a -6, -3 times 2. And then I still have my 3x plus 1 to the 6th and my 2x minus 5 to the -4. And then I have my plus symbol, so plus. And then on this side, we have a 6 and a 3 that can be multiplied together. So that would be 18. And I'm going to go ahead and write these in the same order. So this is going to be 3x plus 1 to the 5th. And you can do that because multiplication doesn't matter what order you write it in. And then 2x minus 5 to the -3. Notice we still have our plus sign right there in the middle. Okay, so what we're going to try to do to finish this, simplifying means that we're going to try to get it into its simplest form. So we're going to see if there's a GCF. So a GCF that we might be able to pull out. It's debatable whether or not it's helpful to pull out the negative symbol on these, because sometimes when you do that, you'll get a binomial left over at the end that has a leading term that's negative, and some people will want to fix that. So it doesn't really matter if you pull the negative out or not. Just be careful. If you do pull it out, it will change the sign of this plus to a negative. And I typically do pull it out. That's just how I teach factoring. but if you don't, you should still have an equivalent expression at the end. And then, so they're both divisible by 6, and I'm going to pull that negative out. And then we have a 3x plus 1, 6, and 3x plus 1 to the 5th, so they have 5 of those in common. And then it gets a little tricky with the negative exponent. Notice that when we had 6 and 5, we pulled out the smaller power. You're doing the same thing here, but negative 4 is actually smaller than negative 3 on a number line. So we're going to pull out the smaller of the two numbers, which would be negative 4. Then we'll have a big bracket. This is going to be our leftovers. So negative 6 divided by itself would just be 1. We pulled out 5 of these, so we still have a 3x plus 1 to the first power. We pulled out all of the negative 4 here. 18 divided by negative 6 would be negative 3. And then we pulled out all 5 of these, so that's gone. And we pulled out negative 4, but we only had negative 3. When you pull it out, you're dividing. So think blob to the negative 3 power divided by blob to the negative 4 power. Blobs are just easier than writing this because that's going to confuse people when you see all the bases. When you have two bases stacked as a fraction, you subtract their exponents if they have the same base, which these do. They're both 2x minus 5s. So when we subtract this, this is negative 3 minus negative 4. That's actually plus plus. So it actually comes out as a positive 1. So we're left with 2x minus 5 to the positive 1 power. Okay, so we're going to work this out. Keep bringing down our GCF. And this would be 3x plus 1 minus 6x plus 15. So I'm going to keep working it out. I can combine the like terms inside. (3x minus 6x would be negative 3x. So see, I did get a negative as a leading coefficient inside here. It's not the end of the world, and honestly, it doesn't matter to most people. It depends on your professor whether or not you have to fix that at the end or not. And then 1 plus 15 is positive 16. So the only thing to fix that we have to fix absolutely is that you can't have a negative exponent. So we will move that one base, the 2x minus 5, to the negative 4 to the bottom. And this will be our final answer. And now it's to the positive 4th power. Okay, let's look at number 4. We're simplifying the expression again. So we've got a fraction over a fraction. We want to turn that into multiplying by the reciprocal. So flip the second fraction upside down. Okay, we can factor the top. So that would be, of the right one, that would be x plus 7 and x minus 7 over 7x. The x, since this is multiplication right here, the x minus 7s can cancel. This is just times 1, so this will be x plus 7 over 7x. Remember, you cannot reduce the x or the 7 here because this is a binomial and this is a monomial. They're not the same type. And to be able to reduce, you have to have matching pieces for the binomials. Okay, let's look at number 5. Number 5 is solving an equation. We have, it looks like, some fractions that we want to deal with. This factors into 2x plus 1 and 2x minus 1, perfect squares. So it looks like my LCD is going to be 2x plus 1 and 2x minus 1. I use a method of clearing out the fractions, but if you do that, you need to remember that there are certain values that x cannot equal in the final answer, essentially setting each of these equal to 0. So that would be a negative 1/2 and a 1/2. So we can clear out our fractions by multiplying everything by 2x plus 1 and 2x minus 1 on both sides of the equation. That's why we can do that, as long as we remember not to let either one of our final answers or just our final answer be the undefined values. If that happens, you would have to say no solution. So essentially what happens here is you multiply each piece by the LCD. What that does is it clears the fractions and it just leaves the numerator times the part that was missing in the denominator. So if we multiply the first one by this, the 2x plus 1s cancel and you have 4 times 2x minus 1. Don't forget your minus sign here. We'll have our 3. The 2x minus 1s would cancel, so we're left with 2x plus 1. And then on the right side, both denominators would cancel out. The pieces would cancel with this that we multiply. So that would just be negative 2x plus 7, just the numerator. We're going to distribute this out, so this would be 8x minus 4 minus 6x minus 3 equals negative 2x plus 7. Combine like terms, that'll be 2x minus 7 equals negative 2x plus 7. Add the 2x over, that'll be 4x. Add the 7 over, that'll be 14. And this is going to be dividing by 4, so that's x equals 14 over 4, which we would reduce down to 7/2. Now, because that's not 1/2 or negative 1/2, the solution should be okay as long as we did everything arithmetic wise correct. So as long as you haven't distributed anything incorrectly, if that's not one of those restricted values, it should be fine. Okay, let's look at number 6. It takes a girl 45 minutes to deliver the papers on a route. However, if her brother helps, it takes only 20 minutes. How long would it take her brother to deliver the papers by himself? Okay, so we have 2 people working at different work rates or different speeds. What we want to do is find a unit way to talk about their actual process. So if and we are assuming in this world that we live in that this person's not taking a break and that they're working at a consistent work rate. So if it takes the girl 45 minutes to deliver the papers on her route, she does 1 out of 45 of her job per minute if she works consistently. If her brother helps, so this is for the girl by herself. If her brother helps, so if they work together, it only takes 20 minutes. So it would be 1/20th of the job per minute. And then we want to know what would happen if the boy worked by himself. So we don't know what his time's going to be, but we're going to call it 1 over x, sticking with this consistent pattern of one job completed in a certain amount of time. So a fraction or proportion of the job. Now, anytime you're dealing with these work rate problems, one way to set it up is to say the 2 individuals added together equal the combo time. We could try to get a common denominator over here, get one fraction and then cross multiply, or we could also try to solve this by multiplying everything by the LCD. The LCD here would be 180x. So if we multiply everything by 180x, let's see what we get. So actually going through and showing the steps for this one of multiplying it times everything on both sides. So 180 divided by 45 is going to be 4, so that'd be 4x. The x's would cancel in the second fraction, so that would just be 180. 20 goes into 189 times, so that's going to be 9x. And then we would subtract the 4x over, so that's 5x, divide by 5, and I believe that goes in an equal amount of times, which is 36. So the boy would take 36 minutes to do the route by himself. Okay, let's look at number 7. 600 people attended the premiere of a motion picture. Adult tickets cost $5 each, and children were admitted for $2 each. If the box office receipts totaled $2,400, how many children attended the event? Okay, so we have 600 people total. So that means if we let x equal children, that's just because I'm going to be solving for children only, so that way I get my answer directly. Sometimes you might want adults to be x. Just depends on if you have to find both pieces of information. So since I'm only solving for children, I'm going to let them be x. We know that the adults and the children add up to 600. So another way of writing adults is 600 take away all the kids. So that'd be 600 minus x. So this is number of adults, number of children. Then this just becomes how much money did each group cost. So children were $2 each. So $2 times x plus, because we're going to have total receipts, that means we're adding, $5 for every adult, so that's the 600 minus x, equals 2,400. So this would be 2x plus, that's going to be 3,000 minus 5x equals 2,400. Combine like terms on the left, we get negative 3x. Subtract the 3,000 over, that would be negative 600. Divide by 3, and we get 200. So since I was directly solving for children by letting them be x, they didn't ask me how many adults attended. They only asked for the number of children. So that would be the answer. If they also needed the number of adults, you'd do 600 minus 200. So there'd be 400 adults. Okay, number 8. Solve the equation using the quadratic formula. This would be a lot easier if we didn't have any fractions, because quadratic formula, remember, is already a fraction. So if you don't have to plug fractions into fractions, it's a good day. So this is negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I could clear out all of these fractions, I could plug in something a little bit nicer into here. Now my LCD for this equation would be 40. So if I multiply everything by 40, I should be able to clear out all of those fractions. So do it to everything on each side. So this would leave me with 5x squared. 40 divided by 5 is 8, but then we have to times it by that 4. So that's going to be 32x minus 40 equals 0. So A is going to be 5, B is going to be 32, and C is going to be negative 40. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so let's get our calculator handy. So we want to do 32 squared, which is 1,024. Then we want to do negative 4 times 5, which is negative 20, times negative 40. So it's a negative times a negative, so it's going to be a positive. So 20 times 40 is 800. And so I'm going to be putting plus, since I ended up with two negatives multiplied together, all over 10. So we want to add together that part inside the radical, so that would be 1824. And my guess is that's a pretty big even number. I'm guessing there's going to be a perfect square that goes into it. So 1824, I'm going to try 4 first. That divides in, but it looks like it might still be divisible by 4 again, so maybe we should try 16. 1824 divided by 16, which is also a perfect square. That'd be 114. If we divide that by 2, that comes out as 57, which is divisible by 3, and that's down to 19. So there weren't any other perfect square pairs that go into this. No other indication that there was a matching pair of numbers. So it looks like we're going to be using 16. So 16 times 114 was what we used to break this down. So that's going to be negative 32 plus or minus 4, because square root of 16 is 4, on the square root of 114 all over 10. Notice that all of your outside numbers are divisible by 2, so we need to reduce that down. So that's going to be x equals negative 16 plus or minus 2 on the square root of 114 all over 5. There's our final answer for that one. And for the last one for this video, and that's also, just as you're aware, 1 through 9 came from Unit 1 in our class, so those all came from your first test. So, and your first review for that test. We're looking at writing this expression in the form a plus bi, where a and b are real numbers. So we're looking at splitting this into two separate pieces, a real part and an imaginary part. To get this to not have an I in the denominator, because remember that's a radical, we have to rationalize. Anytime you have a binomial in your denominator, you rationalize by using the conjugate. The conjugate is the same exact binomial, except the middle sign is changed so that when you FOIL, you don't get any i's left. But whatever we do to the bottom of a fraction, we have to do to the top. So if we FOIL this out, negative 4 times 2 is negative 8. Negative 4 times negative 7i would be positive 28i. 6i times 2 would be 12i. And then be careful here. 6i times negative 7i would be negative 42i squared. We'll fix the I squared in just a minute. On the bottom, we have 2 times 2, which is 4. we get a negative 14i and a positive 14i, and then we get a negative 49i squared. Anytime you have an I squared, remember that really turns back into negative 1. So both of those are just negative 1. So this actually, the bottoms have a middle canceling, by the way. This actually is going to be a positive 49 overall, and this one's going to be a positive 42 once you multiply those together. So let's combine what we know. So negative 8 plus 42, that's going to be 34. 28i plus 12i would be 40i. And then 4 plus 49 is 53. Now we want to split that up into two separate fractions because that's what a plus bi says to do. So you just need to double check that each of those fractions is reduced, and they are. You might have, some people are picky about the I, whether or not it can be on top or not. You could also write that, remember, as 40 over 53i. So I know WebAssign was picky. I think it had to be out to the side. So that's just instead of placing it on top. Okay, so that is the end of part 1, and I will be starting part 2 shortly.